You're probably already familiar with a lot of proportionality relationships. Take the circle for example. The circumference of the circle we know is proportional to the radius. There's a formula for it, but we know that if the radius doubles, the circumference is also going to double. Area of a circle would be another example. We know that area is proportional to the square of the radius. What that means is if the radius doubles, the area actually goes up by a factor of 4. We can use this to help us shortcut a lot of formulas and a lot of calculating. So here's an example. Let's say that some quantity A is inversely proportional to a second quantity B, and we're not completely sure what that relationship looks like other than to say we know for sure it's inverse. And so we know there's probably a constant involved, even though we can't necessarily calculate it, or maybe we don't want to. Say we have two variables A1 and B1, we know they're going to be related this way. There's going to be a proportionality constant involved. Well, what happens if we have a second instance of the variables, and we know that B2 is equal to 4 times B1? Well, we can just use our proportionality to solve this problem. And so we know our second case looks a lot like this. A2 is going to be some constant times 1 over B2. But B2, we know, is equal to 4 times B1. And so really, I could just take B2 and replace it by 4 times B1. If I'm willing to rearrange that a little bit, and I always am, we see that A2 is equal to 1/4 times K over B1, which leads us to a nice place, because I can remember that A1 was actually equal to K times 1 over B1, and so we can actually take K times 1 over B1 and substitute A1. So here we go. Now I can actually see that A2 is just equal to 1/4 of what A1 was. All the proportionalities can work like this, and you don't have to go through a complicated calculation like the one I've just done.